In this unit, we will be solving some quadratic equations using a systematic approach. The title here shows what we are trying to do and include in the following table. We are trying to solve this equation ax squared plus bx plus c is equal to 0, assuming two numbers p and q such that p plus q is equal to b and p into q is equal to ac. We take a problem example 1, which is 2x square. This is 2x square minus 4x plus 10 is equal to 0. Here we can see from this p plus q is minus 4. P into q is 2 into 10 as 20. These are assumed values for p plus q and p into q. We find a variable t whose value is obtained from the sum p plus q and the product p into q. This is calculated and shown here. The purpose here is to be able to find p and q separately by using their sum p plus q and their product p into q. So here p is found as minus 2 plus 4i using this expression. Q is similarly found as minus 2 minus 4i using this expression for q. Alpha is equal to minus p over a and beta is equal to minus q over a. These values are found to be these, and these are the final roots for the equation shown here. Similarly, we take up another example, number 2, and the equation to solve is x squared minus 8x plus 15 is equal to 0. The corresponding values for p plus q is minus 8, written here, and the product p into q written down here. We find t after using this expression as 1. We calculate p as minus 3 and q as minus 5 and alpha as 3 and beta as 5. A similar procedure is followed in respect of the remaining examples. You may have noticed that some of these examples, they have imaginary solution, and some others they have real values for alpha and beta. Here we take the next problem, follow the same procedure, find p plus q as b equal to 5 and p into q as a into c, which is 3 into 2, 6 written down here. T is calculated from this and this. In this expression, we get the value of t as this. Then we find p by this expression and the value obtained is 3. Q is found by this expression and value obtained is 2. Alpha and beta, which are the roots of this equation, they are found as minus 1 and minus 2 by 3. The same procedure is systematically followed for all the examples which are here, and the solutions are all given in the rows, and the titles explain the value in each column. This systematic procedure actually helps you to find the roots of any given quadratic equation very simply without much struggle, and there are not many relations used except for this t, p and q, which are very simple relations to remember, and an explanation for these will be given in one of my next units. After we solve these equations, there is no equation which must be used to find alpha and beta that may not be solvable. I think a reasonable number of solved examples are shown here, and these examples illustrate the use to solve any quadratic equation. Thank you so much.